Let's take a look at practice quiz number 8. This is our rationals unit, part 2. So number 1 says graph the function and identify the key features of the graph. So what I'm going to do first is factor everything out. So in the numerator, x minus 1 cannot factor any further, so I'm going to bring that over. And then in the denominator, it's a trinomial, so I need to multiply to get -6 and add to get -1. I have to think of numbers that can do both. So -3 and +2. Those will multiply to give me -6 and add to give me -1. So I got to write x minus 3, x plus 2. So the first thing I'm going to look for is, are there any holes in the graph? And holes occur when you have a factor that cancels out, and there are none of those. So I'm going to write that there are no holes. And then we can pick out the vertical asymptote. So just look at the denominator and see where would the restricted values be, and those form your vertical asymptotes. So x minus 3 is in the denominator, and we know that cannot equal 0. So then if we add 3, we know x cannot equal 3. So therefore, there's a vertical asymptote at x equals 3. And then the same thing for x plus 2. We know it's in the denominator and it cannot equal 0. Therefore, x cannot equal -2, and that forms a vertical asymptote on our graph at x equals that value. All right, and then the horizontal asymptote, you can just look at the degree of the numerator. So the degree of the numerator was just a 1, and the degree of the denominator was a 2. So since the denominator has a higher degree, it's automatically a horizontal asymptote at y equals 0. Now we just need to graph the function. So I always recommend that you type in the original problem, just in case you've made any errors when you were simplifying. So type it in. You can check all the things that you have found. So you can type in your vertical asymptotes at x equals 3 and x equals -2. And you can see that those do make good sense with the graph. They line up with that place. It looks like the graph won't cross over. And then you can type in the horizontal asymptote at y equals 0. And you can also see that that lines up with the horizontal line that the graph won't cross over. So when you go to graph it, you want to focus on those asymptotes and sketch those first. It's always good to use a highlighter because they're not really part of the graph. They're just going to guide where your graph goes. So put the horizontal asymptote at y equals 0, which is right on the x-axis. And let's put the vertical ones at x equals 3. And x equals -2. And those are imaginary lines, is why we have to write them as x equals or y equals. And then just sketch in the branches. So I see we have a branch over here. We have one up here at the top corner. And then in the middle, it looks like it crosses through and touches at 1. And kind of looks like that. So that would make a nice graph of our function. And that's everything we need for number 1. Number 2 says to find the intercepts of f of x, and it's really the same exact function you had for number 1. And so let's just see, we had an x-intercept at 1, which we just sketched on our graph a minute ago. And then for the y-intercept, let's zoom in a little, it would be at 0.167. So I'm just going to write it the way it looks. All right, so that's it for number 2. You just had to find the intercepts. For number 3, we're given a different function. So I'm going to clear this one out of Desmos and start with this new function. It says graph the function and identify the key features of the graph. So this one's written in a way that we can look at it and pick out the transformations. So I can see that this one has a left-right shift because it has x plus 2 that's in a grouping symbol. It's underneath the fraction bar, in other words. So since this is plus 2, this function is going to shift, not right, it's going to shift to the left. Remember, we change, if it's positive 2, it goes to the left 2. And then it's also going to shift down 5. Remember that number out back, we always think of it as what it looks like. So if it's negative, it goes down. And if it was positive, it would have gone up. And the other thing we look at is the numerator. If it's not a 1, see how this one's bigger than 1? Then this one has a vertical stretch by a factor of 3. And one more thing, it's negative. So when it's a negative out front, it will make the function reflect over the x-axis. So what you want to think about when you're picking out transformations is how does this function compare to the parent function, which would be g of x equals 1 over x. So everything else that got changed about that function, we had to make a note of. So the negative made it reflect, the 3 made it vertically stretch, the plus 2 made it go left 2, because that's in our grouping symbol, and then minus 5 made it go down 5. So your vertical asymptote does still come from your denominator. That will be just where that denominator would have equaled 0, which is x equals negative 2. And notice that goes with the fact that this shifted left 2. Your vertical asymptote is now at negative 2. The horizontal asymptote, you can still look at, actually we look at something a little different this time because it went down 5. It's going to move it from 0 to y equals negative 5. Those are directly related when it's written in this form. So let's go ahead and type it into Desmos. So you have negative 3 over x plus 2, and then out back you have minus 5. Let's hit home, and we can see that we have a vertical asymptote at x equals, I didn't mean to put not equals over here, let me fix that. At x equals negative 2. See how that lines up nicely with what we've got? And then I'm just going to change the color of these to match my paper. Okay, and then y equals negative 5. Notice that lines up with our horizontal asymptote at negative 5. So all of that looks good, and that helps us to graph it. All right, so let's sketch at negative 5. There's a horizontal asymptote. So 1, 2, 3, 4, negative 5. And then x equals negative 2 was the vertical. All right. And then let's just sketch the branches the way that they look. They're in this little area of the graph. Just don't cross over the asymptotes when you're drawing those. That is the most important part. All right, so that's it for the first 3. Let's look at number 4. This one's an application problem. So it says Landon can paint a room in 6 hours. It takes Henry 4 hours to paint the same room. How long will it take them if they work together to paint the room? So we say Landon can paint 1 room in 6 hours. So we set up a fraction to represent Landon's time to paint the room. We add that to Henry's time. So Henry paints 1 room in 4 hours. And then together they paint 1 room, and we're looking for how much time it will take. So we put our variable there. Then we could get a common denominator. So 6 and 4 would both divide evenly into 12. So that would be a good number to turn them into. So you can multiply the numerator by what it would take to turn the denominator into a 12. So since 2 times 6 is 12, 2 times 1 is 2, 3 times 4 is 12, 3 times 1 is 3. And then continue with what we've got. So we got 1 over x still on the right. Then we can add them up. So we have 2 plus 3 would give us 5. We keep the 12. Don't add those together. And then we can cross multiply. So we get 12 times 1 is 12. And then 5 times x is 5x. And so we get 12 over 5. So let's just get a quick decimal of that. And then we can convert it into hours and minutes is a good thing to do. So 12 over 5 is just not how we talk about time. That's why we want to go a little bit further. So we could say 2.4 hours, but then we normally don't talk about hours in terms of decimals. So all you have to do is take 0.4 and multiply by 60 to figure out the number of minutes. So 2.4 means 2 hours and 24 minutes because we just took 0.4 and multiplied by 60 to get the number of minutes. And that is a good answer to know how long it would take Landon and Henry to paint the room working together. All right, the last question is the function p of x equals 35x plus 1200 all over x. Represents the cost per person for prom this year. What is the horizontal asymptote and what does it represent in this situation? All right, so let's just type it in because you can easily pick it out from the graph. We could look at the table. There's a couple things that we could do. So let's put it in parentheses first. 35x plus 1200 all divided by x. You want to make sure that everything is divided. And let's see. So we have a horizontal asymptote that comes from our degree. So it still comes from the same place we looked at in the very beginning with our graphs. You see how you have a 1 over a 1, like the degree is the same in the numerator and the denominator. When it's the same, you take out the leading coefficients. So that means you have 35 over 1. So your horizontal asymptote is y equals 35. And on your graph, it will match up with what you see. So y equals 35 definitely lines up with our graph. But then they've asked us, what does it represent in this situation? So what it represents is the $1,200 that may be the cost of like the venue for prom gets divided among all the people that are invited. So as you invite more and more people to prom, that $1,200 gets dispersed over the people. So like if you look at the table of values for this function and you type in like 100 people are coming to prom, notice the cost is $47. But it goes down the more people you can invite to prom. So 500 people, the cost is going down. Let's see if you invite 1,000 people, see how it's going down. And let's say some unreasonable number. Let's say like we invite 10,000 people to prom. Notice it's still just getting closer and closer to 35. It's never going to be less than that because it costs that much per person to begin with. So let's write out a nice statement. The cost per person for prom is approaching $35. So as you invite more people, the more it will cost them only $35 to come to prom. But the less people come, it's going to cost more per person. All right, so that is it for practice quiz number 8.